This is Trig Identities, lesson 2. What page is this?
11.
So, playing around with trigonometric identities can actually be quite fun. It's a thing that I personally quite like doing.
So then it's going to be boring.
Yeah. No, it's not. It's really fun. I think, Christy, I think you're actually really going to like it.
That's better than that.
It's not drawing graphs or anything like that. No big calculations. It's non-calculator stuff. So it's quite fun. So, but you haven't learnt these trig identities. You've kind of got an idea of one of them though. Write out all the trig identities that are given in your formula booklet. So, to help you, I'll beam up this thing. Remember page 3 of your formula booklet?
No. Yeah.
What? So here they all are. Here's the trig identities. So it's these ones here. Oh, I should zoom in a bit so you can see it.
And I just wanted to participate at first. I was going to.
Okay, guys, you need to be writing down these trig identities. Guys, stop talking about killing people. Okay, so here you go. Here they are. Write them down. So the first one is the trigonometric identity. The pen. The trig identity, which one is it? Equals? Over? Okay, good. You've written that down, Lauren?
Yes.
Okay, well done. Good. The Pythagorean identity?
Pythagorean?
Pythagorean.
Oh.
But you're right. The way you say it is right too. Pythagorean.
I you just said something.
Pythagorean. Okay. So what's that one?
Cos theta squared.
Yeah.
Remember, it's the same thing, Isabella.
Yeah. Something like that, yeah. Sine squared theta equals 1. So I'm in the habit of writing sine squared theta plus cos squared theta equals 1, because when you add the two squares, it's the same thing, whichever way you have it. But in the formula booklet, they do cos squared theta, so I'll try to get in the habit of doing that. So if you see me write sine squared theta plus cos squared theta equals 1, it's the same thing as that one. The double angle formula for sine is that the bottom one?
No.
No, it's the top one. Sine 2 theta equals 2 sine theta cos theta. They're just special formulas that are true because they're true. And it's on the next page we're going to prove the first one and the second one. There's proofs in the textbook about the double angle formula ones, but they go on for quite some time, and you can look at them if you want. And the cos, double angle formula for cos, that's a trickier one because there's more than one version of them. So I'll just go back to, so there's cos 2 theta equals cos squared theta minus sine squared theta. Instead, you could have cos 2 theta, cos 2 cos squared theta minus 1. We could have 1 minus 2 cos squared theta.
So should we write them all?
Yeah, I'll show you. And I've seen the formula booklet, they're given to you that way. So in the formula booklet, they're given to you that way. We're on page 11, aren't we? And I'll just zoom out a bit. So I'll go back and I'll write them on with you. Kia. So the first one was, as you said, tan theta. It was sine theta over cos theta. If you forget them, remember they're in your formula booklet. Pythagorean identity, cos. Sweet, it's getting worse.
Two blockers.
What?
So maybe they hack it on.
Oh, okay. I think you said that sounded like one. As in, like, you know, the guy on Star Wars. Look how he goes.
Hey, Mr. Lenny, where did you get that name from?
He was kind of, that was his nickname before we got him anyway. And then we were like, oh, that actually kind of is a nice name because of his colouring. He actually looks more like an Ewok. He actually looks more like an Ewok, the Ewok names.
What the heck are you talking about?
Do you watch Star Wars?
No.
Oh,
You're going to meet your dog.
Yeah, he's nice. He's pretty weird.
But
Yeah, he's nice. He's pretty weird.
Yeah, great.
He likes to be cuddled, doesn't he? He's easy to hold. He's so soft. Ridiculously soft.
He's skinny.
Please. Sorry, I've just got to calibrate again. It's really bad. And he's still at now.
Paige, are you gonna tell someone the QE?
Well, he never really
Yes, she is. She's gonna tell me the
They sort of do after about a year, don't they?
Is it puppets on the
Yeah, you know when behind the neck sort of smells just like a perfume or a musk. It's really like baby powder. What?
Paige, can you just kill her now?
I- If someone listened to this video, they would.
I feel like Paige has a doctor just that my Paige. Can I help you?
If somebody kills Paige, they get her assignment.
Yeah, but like it's Paige. It's scary when it's Paige.
Also, once you're killed, you have to take it over their murder.
Yeah.
And if they're okay, and if they've killed someone else, so you could take over multiple murder lists. I didn't know that. That's a drain. Okay, so that was that one. And then the last one, as we worked out, was the double angle for cos. Cos 2 theta. Notice it's called double angle formulas because it's sine 2 theta or cos 2 theta. So they're special formulas. And so cos squared theta minus, theta, minus sine squared theta. The other version, so Lauren, the way I tend to write them out, in the formula book, they're best write them all running across the whole page. But in my little thing, my referencing, I find it just easy to write them all out underneath each other. Or 2 cos squared theta minus 1. I just wrote equals minus 1. Equals on the other one, 1 minus 1 minus. Honestly, look at how bad that is. One day we'll get a good board.
It's funny if you scroll up, it'll fix it on the way.
Yeah, it does, doesn't it? It's when you find it down the bottom of the board. It's bad, isn't it? This is so annoying. Thank you. 1 minus. What are you saying?
It just doesn't like minus.
Let's see if you drop.
You're on the friend group.
So bad.
Miss Maloney, did you get a plus?
Huh? Is that a plus? No. Sorry, this looks like one. There they are. Okay, that's the best we can do. So see there's 3 versions of the double angle formula for cos. There's this one, there's this one, and there's this one. There's 2 different versions. It turns out someone did all these investigations and found that they were able to do these manipulations and find that this right-hand side equals the left-hand side for all thetas, for all angles. Someone just did some explorations years ago. And so, there's proofs for this on some page, on page 457 and 458 for the double angle formulas. So of the textbook. So I'll only prove the first 2 to you right now because they're nice and quick to prove. But the other 2 are quite detailed to prove and you don't need to know the proofs. So I don't want to waste your time. So this one, the top one you're pretty familiar with already. Yeah, here we go. So now let's do a quick, you've got that down already? Great. So now let's do a quick proof. Oi, what are you doing?
Killer.
Oh dear, seriously?
No.
Okay.
Nobody can die in the class.
Oh, okay, yeah, because that's fair enough, because you're trapped in those. So now we're going to prove to the first 2. We're just going to prove the first 2 because that's quick. We'll prove the first 2 here using the unit circle and basic trig.
Well, now I know what it stands for. Yeah, never mind.
For a proof of the double angle formulae, see pages 457 and 458 of your textbook. So the trig identity proof. Using, what do you think? I'll give you a clue. Let's do a little hangman.
A.
E.
Oh, yeah, okay. Yeah, let's do proper hangman. Okay.
A.
So
Oh, thanks. So I guess got it. So it's proof using SOHCAHTOA.
That's probably the only thing I'm going to remember from math in 20 years' time.
SOHCAHTOA.
And then you'll be like, what does it mean?
What is the point of this?
This is hard.
Yes, it's pretty interesting, isn't it?
No, I like this.
Angles and stuff. So this is quadrant 1. So remember, I tend to call this point P just a point P on the circumference somewhere, and we're in quadrant 1. What am I going to do that here? So remember on page 6, we proved that the y coordinate, or the height of the triangle, is always close.
Sorry.
Yeah, good. Sine theta. So sine theta is always the y coordinate. And what is the x coordinate of P always? This length here on the bottom? Cos theta, yeah. So we proved that on page 6. So just maybe make a note. On page 6, we proved that the x coordinate of point P is cos theta, and the y coordinate is sine theta. So we're not going to bother proving that again. And then the trig identities is for tan theta. So if you, according to Sokotoa, tan theta is opposite over adjacent. So we know as tan theta equals opposite over adjacent, and theta equals, so what, on this triangle, on here, what's the opposite of the angle?
Sorry.
Yeah, sine theta. So the opposite is sine
Oh,
theta.
that's why it's there.
Yeah. And the adjacent is
This is hard.
cos theta, exactly. So that's a quick little proof. So it's just using Sokotoa. And in a way, because we've already proved that this is sine theta and this is cos theta, I didn't include that. Because we already on page 6 proved that. So that's a proof of why tan theta equals sine theta over cos theta. Then we're going to prove the second one on down below that some people are writing.
Oh no. You know that today I had chicken wings for lunch with rice, and I brought the wrong container that just had rice and vegetables in it.
What's wrong with that?
Isn't that just sad?
Where's the chicken?
At home, I left it at home because I brought the wrong container because they all look alike in my fridge.
Will you put it with your lunch tomorrow?
Maybe just chocolate for your lap.
Yeah.
Yeah.
Like, no one thinks about that.
Yeah, because you think, let me just grab and go, you know.
Why didn't you put the chicken in it last night?
No, this one. I had a container with chicken and rice in it, and another container with just rice. And I took the just rice container and not the container with the chicken and rice.
Why did you have a container with just rice in it then?
Because it was just leftover rice. Like, it would have been too much rice if I had it all in one container. And that's why I feel fancy.
Ah, okay. Were they identical looking containers?
Yes, yes,
Well, you
yes.
should have stuck one on top of the other. That's the only way I get. That's the only way I get this thing.
If I would have stayed at home, then I wouldn't have had this. Yeah.
Well, instead you got to get KFC.
Yeah,
I have no sympathy.
With a burnt biscuit.
Okay, you've got that already. No, still ready?
I agree, Catherine.
How come you didn't get a burger in KFC?
She just wanted some.
That's what KFC does to you.
Wow.
Because you've been lining up for so long. Why didn't you get a burger? The burger's very nice.
Oh no, not KFC burger. Yeah.
No, they're not.
They're
They're a bit soggy, are they?
KFC burger.
like the zinger sandwiches.
Oh.
Like a chicken burger, right?
What's good from KFC?
You just said it.
The fries are nice. They're crinkle cut fries here, aren't they?
Is the top point, is that a P or a T?
That's a P for points. P. Oh no, it didn't. That looks worse. Thanks, Lauren. Okay, the Pythagorean identities.
And I was younger.
Yeah, they. Oh,
I think.
no, I'm asking you a question. Yes, I'm asking you an answer.
I don't know.
The Pythagorean using these. What is doing? No.
What's your life? I'm very boring. You always just show the answers every single time. Whatever, Sarah.
All of us are here.
Yeah.
Sarah.
Lauren just spoke what I was thinking.
Remember, I've got a lazy eye, so I can't. I used to sit over there. I forgot the G. Pythagorean theorem.
No, it's sitting.
That's hilarious, though. Dog.
Ah, okay. So the
Why can't
Pythagorean.
you just write properly, Miss Lady?
I do. I promise. And then Pythagorean theorem. So to do this thing, we need to draw another triangle again. That's okay. So let's draw a triangle again, just to practice doing this stuff. It's a point P, and we've got a little angle here, theta. The angle's always with the x-axis, theta. And our x-coordinate, is cos theta, and our y-coordinate is sine theta. Just reminding ourselves of these things. Cos theta, and it's a right angle triangle. If you want to remind yourself of that. It's cute. What's the radius of the unit circle, boys?
1.
Good. So the radius of the unit circle is 1. So let's mark that on the triangle too.
Wait, where's that triangle? You just do that again?
Yeah.
Obviously, you never do.
Yeah, I do.
That's a 1.
Why you do it?
So that's a 1. So don't forget the little 1 on there. What am I trying to do? Okay, Owen, what is the Pythagorean theorem again? A squared plus
B squared.
equals
Yay. Good. It's like when she comes into math, it's like different presents. Like she just.
and so a squared, a is, for example, cos theta. So you could put it sub in cos theta, so cos theta in brackets squared plus sine theta in brackets squared equals 1 squared, the hypotenuse squared. And how do we write cos theta squared? What's the way we tend to write it instead?
So it doesn't matter which one's A, which one's B, right?
No, doesn't matter. They just call the legs, doesn't matter the order you put them in. So how do we, instead of writing cos theta in brackets squared, in maths out, what's the way we tend to write it? It was on one thing. You want to guess?
If I say something, we're going to get mad at me, so I'm just going to be quiet.
So instead of writing it with brackets, what's the way we tend to write it in math?
Cos squared theta.
Yeah, exactly. So instead write cos squared theta plus sine squared theta. What's 1 squared?
Theta.
What's 1 squared?
I think it's 1.2 and wrong.
There you go. So yeah, there you go. Just proved it.
That's what I mean. I have to keep it on
You call your grandma.
All right. Let's go. Okay, yeah, that's it.
No.
We're just going to kill someone.
No. It's a little toy car.
It's too big.
Oh no, she's going to tell someone to kill you.
No, she's.
It's fun sitting there. It's fun. It's like, hey, we're on my arm, your days are limited. Like max.
I like when you guys. I'm not so stressed.
It's only the first day.
And so many people have died. I'm like, I'm gonna be nice today. I'm not gonna kill anyone.
And then everybody's like,
You need to act with it.
Yeah, or someone's going to kill you
yeah.
while you're trying to kill someone. Like what happened to you?
I'm gonna kill my person tomorrow.
You
Who will it be?
No one knows.
Don't kill me because honestly I won't be thinking.
Okay. Oh, Lauren, everyone's got this. Okay, so now we're on the next thing. We're on the next thing. Notice it's all no calculator. It's all no calculator stuff, which is quite fun. So given that cos theta is 4/5 and theta is between, what's pi over 2? 90 degrees. Good. Yeah, let's just practice kind of like converting in case it helps. So 0 to 90 degrees. So it's the same thing. What quadrant is that?
1.
So that's quad 1. Given that cos theta is that thingy, so does that make sense? It's quadrant 1, so cos theta is positive. That's why they've got a positive answer. If they wrote negative, it's probably because it's in a quad 2 or quad 3. So find the exact value of sine theta. So just be aware, in quad 1, is sine positive or negative?
Positive.
Yeah, so your answer needs to be positive. But, so you might just want to make a note. Sine is positive in quad 1. And then just make sure, like, you'll probably get a positive answer. Yeah, no worries, yeah. And so this is probably pretty straight up because you're probably going to get a positive answer. But if it happened to have been negative, then you would have to change the positive to a negative at the end. So I would suggest, the hard thing is sometimes you're like, oh, what trig identity could I use and all this kind of stuff. You could use the Pythagorean one. So the Pythagorean trig identity, you could use cos squared theta.
Wait, why are we doing that one, Miss Rose?
Because
We have the most information.
kind of, yeah. Like for me, all we need to work out is, we know what cos theta is.
Yeah.
We've got to be able to sub it into something to work out what sine theta is.
Yeah.
And so for me, if I looked at my list, like you know that page I gave you,
Okay.
where page 11, where I got you to write them all out,
Just use
sometimes having that out is helpful. Or your formula booklet's got them as well. So this page is the thing you want to kind of look at. So when I looked at all of those, I thought, oh, I can't use the tan theta one because I don't know tan theta. Yeah. So if tan theta was in there, I'd probably consider maybe using the tan theta one. But it's not, and there's no double angles. There's no cos 2 theta or what sine 2 theta. So I eliminated those ones and that one, and so that one's the most sensible one because the number 1 is a number, and cos 2 theta you can turn into a number, cos squared theta. So cos squared theta. So we've replaced the cos squared theta with 4/5. Remember cos 4 is 4/5. So cos squared theta, would you agree, is 4/5 squared? Because if cos theta is 4/5,
Yeah.
Yeah, because I was about to sub in 4/5 by mistake, and then I realised, hang on, it's cos squared theta. And then you can fill in the rest. Plus sine squared theta equals 1, and then we just rearrange and start to solve.
No way, that's her.
Just to let you know.
No, that was pretty quick. We scared them.
So now you might just want to write sine squared theta equals 1 minus. So now you just might want to start rearranging. So 4/5 squared, we stopped in cos theta here, and cos theta is 4/5, but don't forget it's cos squared theta, so don't forget to square it.
Okay.
And then we're going to solve for sine squared theta, so sine theta eventually. So sine squared theta is 1 minus, what's 4/5 squared?
It's 1.
16.
5 minutes. 16/25, good.
You can't tell the time.
So what's interesting is 1 minus 16 over 25. How do you work that out?
You make that over 25.
Good, exactly. So sine squared theta equals
They're going first.
equals 25 over 25 minus 16 over 25. So maybe you want to save a bit of space. Just go sine theta equals the square root of, save space, maybe go straight to the square root of. What's 25 over 25 minus
9 over 25.
Yeah, 9 over 25. And remember, you can break the square root up into square root of 9 over square root of 25. So maybe I'll do that here.
Wait, what's 15 anyway?
So what does that equal?
3 over 5.
Good. So sine theta equals 3 over 5. And just double check, have we got the positive? Is it meant to be a positive or negative answer? So just double check. Yeah, good. So guys, that was an important point. Is it meant to be a positive or a negative answer?
Positive.
Yeah, positive, yeah, because it's quadrant 1. Yeah, and sine's positive in quadrant 1. So see how that's why I chose to do that one.
Thursday, February.
And now let's do, so now notice what's special about sine 2 theta. Which formula do you think would be a good one to use? Good, the double angle formula for sine. Perfect.
Double angle.
Let's use a double angle.
Should I use it first?
Sine 2 theta equals 2 sine theta cos theta. You just start to know these after a while. So don't rely on your memory. Double check with the formula booklet. Because you don't want to get written down the trig identity wrong where it was in the formula booklet the whole time.
That was far.
Yeah, that'd be annoying. And there's quite a lot of stuff going on in your brain during the exam, so you don't know. Do we know what sine theta is?
See,
Yeah, what is it? 3/5. Bella! What's sine theta equal to again? Attention please. What's our sine theta equal to? 3/5, good, yeah, well done. What's our cos theta equal to according to the question?
4/5.
4/5, good, yeah, so all you do is sub those two things in. So, and then you'll get the answer. Equals 2, what is it again? 3/5.
are you really salty? And then 4. That's cool.
Now this is interesting. How do you work this out non-calc? I would suggest work out the fraction you get first, times the two fractions together if you like.
Oh yeah.
What's 3 times 4?
Wow.
Wow.
Good. Over 20, oh sorry, over what?
25.
Yeah. And then what's 2 times 12 over 25?
24, 25.
Yeah. It's like, if you're struggling, it's 2 over 1 times 12 over 25.
We were struggling.
And just notice, it makes sense, oh yeah, so no, that's
We
fine.
have 2 minutes, Isabella.
So just turned out we came up with a positive answer.
Oh my god.
This does make sense because if you've got an angle in quadrant 1, so guys just be aware, if you've got an angle in quadrant 1 and you doubled it, so if you had a tiny angle like 15 degrees, if you doubled it, would it still be in quadrant 1?
Yeah.
Close? It could be, or it could be in quadrant 2. So something like 15 degrees, if you doubled it, it's 30 degrees. It's still in quadrant 1. And if you doubled it, it's still in. If you had an angle like. If you had, we've still got 2 minutes going. You're gonna go late. You
No, that much wrong is 154.
It's actually so. Come on, I want to finish this before we go. So if we had an angle like sine of 80, if you doubled it, what would you get?
160, so it'll be in quadrant 2.
Quadrant 2, yeah. And sine positive or negative in quadrant 2?
Positive.
Positive, yeah. So that's why it's like you still have a positive answer. You guys go off to your thingamajiggy, your social media. So, see ya. Good work. Don't get killed. Stay alive.